So a conducting rod PQ is rotating an uniform magnetic field about an axis passing through O with a constant angular velocity omega. One end of the rod is at a distance A and the other end of the rod is at a distance B from O as shown in the figure. Find the induced EMF across the ends of the rod. Okay, so it is a rotating rod in a uniform magnetic field. So in this case, we have to divide this entire rod into small strips, small elements. Consider a small element at a distance dx from the axis. So now, since the rod is rotating, this small element will go in a circle of radius x, and the speed will be, it is v, the speed will be x into omega. The speed will be x into omega. So this is the linear velocity. So we have relation between angular velocity and the linear velocity, angular speed and linear speed, v equal to r omega. So here r equal to x. So now here each element, when you divide this entire rod into small elements, each element or each strip of the rod behaves like a moving rod. So each strip behaves like a cell. All the cells are in series. So to get the total EMF, we have to integrate. First, we calculate what is the motional EMF in the small rod, small strip. The motional EMF in the small strip is given by BVL. B is constant. V into DL. BVL. So the L of the length of the small strip is dx. So dE is equal to B, V is equal to x omega and dx. So dE is equal to B omega x into dx. This is a small EMF producing the small element. To get the total EMF, you have to integrate. Why we are integrating? Integration means addition of small quantities, similar quantities. Here, why we are adding all the EMFs? Because all of them are said to be in series. So B omega x into dx. Limits of x will be A to B, A to B. So the total EMF is given by B omega x square by 2. Limits are A to B. If you substitute the limits, you will get B omega. So B square minus A square divided by 2